Hey, geometry students, we're in section 8-2, and in this section we have some new vocabulary. We have Pythagorean triple. Alright, so we have this theorem called the Pythagorean theorem, and in a right triangle, the sum of the squares and of the lengths of the legs is equal to the square of the length of the hypotenuse. What that basically says is if we take the side BC, which we're calling length of A, and we square that value, and we add that to the square of B, then we get the square of the hypotenuse. So again, if we take this side length and square it, and we take this side length and square it, and we add them together, okay, then you get the value of the hypotenuse squared. Example would be like a 3, 4, 5 right triangle. 3 squared is 9, 4 squared is 16, and if you add those together you do get 5 squared, which is 25. Okay, Pythagorean theorem says given triangle ABC with right angle at C. So this is just the proof of the actual theorem, and so you won't actually have to worry about knowing the proof. But here it is in case you want to look it over. Okay, now we're going to find missing measures using the Pythagorean theorem. We know that the side lengths here are 4 and 7, and the reason why we know that is because the hypotenuse is always directly across from the right angle. So x length is my hypotenuse. So what I have here is that 4 squared plus 7 squared should equal x squared. And then we can solve for x. So we have 4 squared plus 7 squared equals, and they're calling it c, just using the letters A, B, and C. And therefore, when we solve, we have 65, because that was my 49 plus 16, and then we can solve for c by taking the square root. So c equals the square root of 65. Okay, here we're going to try to find x. What we want to know this time is not the hypotenuse length, because the hypotenuse length is 12. So this is a side length that's missing. So it's going to be side length squared plus the other side length. My other side length is the 8. And we're going to square that. And that should equal 12 squared, which is the hypotenuse squared. So as we do this problem, we just have to square the 8 and then subtract it from both sides of the equation. So the hypotenuse is 12. So therefore, again, Pythagorean theorem. And there's our equation. And then we're going to solve by subtracting 64 from both sides and then take a square root. So the side length is the square root of 80, or reduced down to 4 square root of 5. Okay, check your progress. Okay, go ahead and pause your video and solve for the hypotenuse. Okay, it's the square root of 89. And we find that by, these are my two side lengths. We're solving for the hypotenuse. So we have 5 squared plus 8 squared should equal x squared. We have 25 plus 64, which is 89. So we have 89 equals x squared. Therefore, x equals the square root of 89. Take the square root of both sides. Okay, check your progress. This time we're finding a length of one of the sides of a right triangle. Go ahead and pause your video and solve for x. Okay, this time the answer is 6 square root of 3, or you might have got also 108. Let's see how that was found. So we're solving for a side length. So we start off with x squared plus 6 squared, and that should equal 12 squared. Subtract 36 from both sides, and we get 108. So then the answer ends up being the square root of 108. Okay, now you may wonder how they got 6 times root 3. Well, 108 is the square root of 36 times the square root of 3. And the square root of 36 is just 6, so it reduces down. So either answer is correct. So 6 root 3 would be an answer, or square root of 108. But 6 root 3 would be considered the reduced answer. All right, now we have something called Pythagorean triples. And sometimes it's helpful to memorize some of these. Okay, if you notice right here, you have the 3, 4, 5 right triangle, and that's the first example that I gave you. Whoops. Okay. And then if you notice here, each one of these, this one's times 2. Okay, all the way across. So 3 becomes 6, 4 becomes 8, 5 becomes 10. And then this one's times 3. And then basically, it's just 3, 4, 5, the original sides, multiplied by any positive integer, would give you another Pythagorean triple. So if we had 3, 4, 5, I guess we could multiply by 5, and we get 15, and multiply by 5 here, and you get 20, and multiply by 5 here, 25. What that means is these 3 sides could form a right triangle. 15 squared plus 20 squared should equal 25 squared. Let's check it out. 15 squared is 225. 20 squared is 400. And it works out that 25 squared indeed is 625. And it also works for these other Pythagorean triples. Okay, but this is the one, the most common used one is 3, 4, 5. Okay, use a Pythagorean triple to find x. Explain your reasoning. Okay, so we have 24, 26 as a hypotenuse and x. So if you look back, 24, 26, look back at the list. You can see 24, 26 is in the second column there, and then a 10. Okay, so notice that 24s and 26 are multiples of 2 times 12 and 2 times 13. So we're using that one. So Pythagorean triple, the missing leg is 10. All right, use Pythagorean triple to find x. If you need to, go back and look at that chart. Or you also could just take 39 squared minus 36 squared and then take a square root. And the answer is 15. Okay, here's an example. This will be the last example. We have I think it's the last example. We have a 20-foot ladder placed against a wall, reaching a height of 16. And we'd like to know how many feet away from the building is the bottom of the ladder. Well, if you notice right there, it forms the little triangle area, right? This space right here is a right triangle. And we have then a hypotenuse of 20. So we're going to have x squared plus 16 squared should equal 20 squared. So x squared plus 16 squared, and 16 squared should be 256, and this should be 400. And then we're going to subtract and then take a square root. Can you think, well, you might want to make a guess here? You're right. Okay. Oh, didn't give an example. It didn't give an answer, did it? Well, the answer should be 12. Subtract 256 from 400, you get 144, and then take a square root, and you get 12. Oh, here it is. Here's the example. Here's explaining it. So the answer is 12. Method 2. Solve it just like a little algebra. That's what I did. Answer is C. Okay. Standardized test example. Check your progress. Go ahead and pause the video and see if you can answer it. Okay, the answer is a 10-foot ladder is placed against a building. Base of ladder is 6. Right, so we have, here's my ladder, here is 6 feet, and here is the wall, the building. So we're looking for this distance here. We can call that B. We know this is 6 and we know this is 10. Oops, this is a B, not a 6. That's B. So we have 6 squared plus B squared equals 10 squared. So B squared should equal 100 minus 36, which is 64. And take a square root and you get 8. Alright, so those are the last example, like I thought. And then here is the converse of the Pythagorean theorem. It basically says, if the sum of the squares of the lengths of the shortest sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. So by checking that, we can know it's a right triangle. And if it's not a right triangle, then obviously that won't work. Okay, so here we go. Pythagorean inequality theorems. It says the following. All right, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the two sides, then the triangle is an acute triangle. So if the longest side, C, and you square it, is less than the sum of the other two sides squared, then the triangle is acute. Okay. Also, just the opposite, if the largest side when squared is greater than the sum of the other two sides, then it's obtuse. So think of the word, the longest side being greater than 90 is obtuse. Less than 90 is acute. Okay, determine whether 9, 12, 15 can be measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. Justify your answer. Okay, so determine whether the measure can form a triangle using the triangle inequality theorem. So something that we have not covered, but here it is, right? We take the two sides, add them up, and it has to be greater than the third side. So 9 plus 12 is greater than 15, 9 plus 15 is greater than 12, and 12 plus 15 is greater than 9. Therefore, it can be a triangle. Now, we're going to see what type of triangle. Does it fit the c squared equals a squared plus b squared? So we'll take 15 squared and compare it to the 12 squared and the 9 squared. And we get 225 equals 225. Therefore, this particular problem, this is a right triangle. Okay, determine whether 10, 11, and 13 can be measures of sides of a triangle. If so, classify the triangle as acute, right, or obtuse. Justify your answer. Okay, so 10 plus 11 is greater than 13. 10 plus 13 greater than 11. 11 plus 13 greater than 10. So yes, this can form a triangle. Okay, and now what we're going to do is check to see if it fits the Pythagorean theorem. So when we check this time, we end up with 169. Okay, that's the longest side, and we square is less than. Remember? So the longest side is less than 90. Think of it, that would be acute. So therefore, the triangle is acute. Check your progress. Okay, pause your video and check to see if you know if this is acute, right, or obtuse. The answer is that it can be formed to a triangle, and let's show you why. Because 7 plus 8, right, is greater than 14. Okay, 8 plus 14 is definitely greater than 7. And then also our 7 plus our 14 is greater than our 8. Okay, and then we take the 14 and we square it. And 14 squared is 196. And then we're going to square the 7. and we're going to square the 8. And then we're going to add those together. And that ends up being 64 plus 49 is 113. And definitely 14 squared, okay, 196 is greater. Okay, so remember, this is always write down your hypotenuse, or I'm sorry, your longest length squared first. That way, this will be a good way of remembering. So 196 is greater than 90, right? Sorry, 196 is greater, right? When we say greater, we think greater than 90, which makes it obtuse. Okay, determine whether the set of numbers 14, 8, and 33 can be measured sides of a triangle. Okay, we're going to pause the video and see if you can get the right answer. Not a triangle. And the reason right away is because 14 plus 18 should be greater than 33. But it's not, because 32 is less than 33.